Hi, everyone. I'm just going to do a video on the pre-assessment for the final. So hopefully you are ready for this come next week. Let me just put on my share screen portion and we will get started. Okay. All right. So number one, I'm just going to do it on a blank canvas. So it's going to take some time for me to write each problem down, but we have x to the negative fifth power, y to the second power over x cubed and z squared to the negative 3 power. Okay, this should be a little bigger. All right, so for me, I like to get rid of all negatives. All right, so I'm going to move all the negatives and I'm going to focus on the inside first. So it's going to be y squared z5, sorry, x5, x to the fifth power, x to the third power, z squared. Again, this negative makes the whole expression go down to the denominator. And then what we have is to the negative 3 power. The negative, I'm going to get rid of the negative. The negative flips over the equation. So it'll be x to the 8, because the 5 and the 3, z squared all over y squared to the third power. Okay. Then I'm going to multiply the 3 to each exponent. So the final answer is x to the 24th power, z to the 6th power over y to the 6th power. That is your final answer. Number two, or letter B, sorry, 1 over 64 to the negative 2 over 3 power. So the inside is already complete, like we don't need to do anything with that, but this negative is right here. So we're going to flip it over 64 over 1, which is just 64 to the 2/3 power. And this becomes 64 squared, the cube root of 3. 64 squared is 4096. So the cube root of 4096. The cube root of 4096 is 16. Okay. And that's your answer for 1A and B. All right. Here we go. Number two is rationalize the following. This is a really key concept because this is the cube root of 5. And what we want to do is, remember, we had to get rid of the radical. And we want to multiply by the cube root of 25 because 5 times 25 gets us a perfect cube here. So this equals 3 cube root 25 all over. This is the cube root of 125, which is just 5. And that's your final answer. No, letter B, remember to do the conjugate. So it'll be 5 over 7 minus radical 2. Multiply both the top and the bottom by 7 plus radical 2. Remember, this is in parentheses. So if I multiply the top, the distribute property, so it'd be 35 plus 5 radical 2, all over 49 plus 7 radical 2 minus 7 radical 2 minus radical 4. This ends up equaling 35 plus 5 radical 2 over, these cancel out. This is 2, so it'll be 47. Number 3 is the binomial expansion. All right, because whenever it says x plus 4, oh sorry, it's x plus 2y to the 4th power, right? Something like that, you have to use the Pascal's triangle. So this is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This is x squared, x to the 3rd, x to the 4th power. So we're going to use this row right here. Okay. So we're gonna use that last row, the 1, 4, 6, 4, 1. Okay, and then as the first term it decreases, the second term increases. So it'll be 2y to the 0 power plus x to the third power, 2y to the first power plus x to the second power, 2y to the second power plus x to the first power, 2y to the third power plus x to the 0 power, 2y to the fourth power. Remember, if this was a minus sign, it would alternate minus, plus, minus, plus. Okay, so just be aware of that. Okay, so now we put the Pascal's triangle here, put the 1 and then the 4 and the 6, 4, 1, and then we multiply everything out. So x to the fourth is just x to the fourth. That's done. This is to the first, so 8 x cubed y plus, so remember, make sure to do the 4, right? Do the exponents 4, exponents first. 4 times 6 would be 24 x squared y squared plus 8 right here, 8y cubed. 8 times 4 is 32, so 32x y cubed. And then plus 2 to the fourth is 16y to the fourth power. That is your answer. Okay. Number 4 is factoring. All right. We have x cubed plus 216. Remember, this is the sum of cubes. So that formula is a cubed plus b cubed is equal to a plus b, a squared minus ab plus b squared. Okay, so a cubed is equal to x cubed, which means that a is equal to x. B cubed is equal to 216. That means that b is equal to 6, because if you get the cube root of both the x cubed and the 216, it'll be x and 6. So now just plug it in. X plus 6, x squared minus b is 6, a is x, so 6x plus 36. And that is your final answer. You factored it. Letter B is, remember that the leading coefficient is not 1, so you're going to have to use the x method, but there's an extra step. So remember, this is 48, negative 48. This is negative 13. So negative 16 and positive 3. Remember to use this 3, put it on top. Simplify 1 and 1. So it will be 3x minus 16. The top number goes in front, the bottom number goes here. And then this is 1x, top number 1, bottom number is 1. So this is your factored equation. Using the given transformation, remember for number 5, the cubic function, it was y is equal to a and then x minus h cubed plus k. So the cubic function, so it'll be y is equal to vertical shrink, you just take it as is. You reflect off the x-axis, so you're gonna put a negative sign in front of the and then shift left 2, so it'll be x plus 2 because you're going to the left. You're taking the opposite sign, cubed plus 5. Okay. Be careful when it's horizontal. Remember that you're taking the reciprocal, and make sure it's inside of the parentheses. Okay. Solve for the following equations. Number 6. It looks easy, but it's a little tricky. X squared minus 5x is equal to x squared plus 1. Remember when you have a quadratic, which is the squared, like you have to put it in standard form and then subtract 1. So it'll be x squared minus 5x minus 1 is equal to 0. Am I right? X squared, sorry, x squared minus 1. Okay, so then you have to use a quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. A is 1, right? That's a number here. B is negative 5, and C is negative 1. So negative, and then negative 5, plus or minus the square root of negative 5 squared minus 4 times 1 times negative 1. All over 2 times 1. We put this together, that'll be 5 plus or minus the square root. This is 25 plus 4, which is 29, all over 2. So if we do this, it'll be 5 plus radical 29 over 2, 5 minus radical 29 over 2. So radical 29 is equal to 5.38. So 5 plus 5.3, let's say 9 over 2, and 5 minus 5.39 over 2. That is 10.39 divided by 2. And this is negative 0.39 divided by 2. So 10.39 divided by 2 is about 5.195. And then negative 0.39 divided by 2 is negative 0.195. So also keep in mind that, again, these are the zeros when you guys graph these. So 1, 2, 3, 4, 5. And so 1 0 is here, and then the other 0 is like right here. Okay, those are the solutions to the problem. Okay. Number 7, it is x cubed minus 5x minus 2x squared plus 10 is equal to 0, and you want to group them. So it's x, and then it'll be x squared minus 5. Take out the negative 2, and it'll be x squared minus 5. So the final answer, or when you factor, it'll be x minus 2. That comes from here, and x squared minus 5. So if it has to solve, it is x equals 2, and x is equal to the square root of 5, because remember, when you do something like this, you add the 5, it'll be x squared is equal to 5, you get the square root, so x is equal to 5. Okay. All right, number 8, it's kind of a long one here. It's radical x plus 16 is equal to 3 plus radical x minus 2. Okay, you're going to square both sides. But when you square both sides, you're not just squaring the 3 and this separately. You have to FOIL it out. So it will be x plus 16 is equal to, and then you have to FOIL it out. So it'll be 3 plus radical x minus 2, 3 plus radical x minus 2. If I FOIL this, it'll be 9 plus 3 radical x minus 2 plus 3 radical x minus 2 plus, and then this times this is just x minus 2. So combine like terms. So this will be, and then combine like terms will be 9. Oh, sorry. This will be 7. Plus x, right? So the 9 minus 2 is 7. Plus x is gone. Let me do it. And then there's a plus 6 radical x minus 2 equals x plus 16. And so I subtract the 7, subtract the x. This is what? 0. This is 9 is equal to 6 radical x minus 2. Divide the 6. So it'll be 3 over 2 is equal to radical x minus 2. Square both sides here. So it'll be 9 over 4 is equal to x minus 2. Add the 2 to both sides here. So it'll be 9 over 4 plus 4 over 8 over 4. So it'll be 17 over 4 is the answer. Number 9 is just, going way back in algebra. There's a linear equation right here. There's a line. So you have to get the slope of this line because it has to be perpendicular to this. In order for you to know it's perpendicular, you have to get the slope. And then once you get the slope, you have to get the negative reciprocal of that. So if I get the slope, it would be negative 3x, subtract 3x. It'll be 2y is equal to negative 3x plus 2. And you divide by 2, y is equal to negative 3 over 2x plus 1. You could also do, again, recognize that this is in standard form. So you can just write in this case, you go write negative a over b. This is the a, this is the b. So m is equal to negative 3 over 2. So look at the slope here. It's the same answer. Okay. And remember, when you want to get a slope of a line that's perpendicular, you have to flip it over, which is 2 over 3, and then get rid of the sign. So the new slope, the perpendicular slope, is positive 2 over 3. On top of that, remember, it has to go through the 0.62. So you want to use maybe point slope form. You'll plug it in. So 2 is y. The slope is 2 over 3, and then the x1 is 6. You also may want to use the slope intercept form. We already know the 2 over 3x, but we don't know the b yet. So you want to plug in the numbers, the 6 and the 2 in temporarily, just so that we can find the b. So I cancel, so that'll be 2. So that'll be 2 times 2 is 4. Plus b is equal to 2. So you subtract 4. So b is equal to negative 2. So y is equal to 2 over 3x minus 2. It's another way of saying that. Number 10 is 3 minus 4x squared, and then you have to find the g of 3. That's the g of x. All you're doing is just plugging in the 3 in for this, so be careful though. This is 9. 4 times 9 is 36. 3 minus 36. Right? This is 9, yeah. This is negative 33. Number 11 is the f of g of x. Remember, these are composite functions here. So you take the g function of 4x, and there's the f of x function. I should put this here, of x plus 4. So you start with a g and then plug it into the f. So it'll just pretty much be 4x plus 4. We're just plugging in the 4x in for their x. So it's 4x plus 4. Cool. If we get the inverse, number 12, y is equal to negative 1 over 3x plus 1. All we are doing is switching the x and the y. All right, so switch the x and the y. Subtract the 1. And what you want to do is you want to solve for the y. So it'll be negative 1 over 3. Y is equal to x minus 1. Multiply both sides by negative 3. Right? And so this is what? Y is equal to negative 3x plus 3. Okay, that was number 12. Number 13, notice that the graph is reflecting over the y axis, so it is even. check over the graphs of even and odd functions and you will get that. Okay. Number 14 is graphing a polynomial. It is x cubed plus 2x squared minus 3x. We have the y is equal to that. Remember, we factor out the x. It'll be x squared plus 2x minus 3. And we factor that, so it'll be x plus 3, x minus 1. So our three zeros are x equals 3, x equal to negative 3. Remember, we're making this equal to 0, subtract the 3, and then x is equal to positive 1. We graph. Here's 0. Here is 1. Here is negative 3. All right, so what we have to do is we have to find points in between these zeros so we kind of see what the graph's doing. Okay. But remember, this is the odd function, so it's going up on the right and going down on the left. Okay. Now if you plug in 2 into this, I'm gonna plug it in. You can plug it into the original equation or in factored form. I'm gonna do a factored form. It would be 2. If I plug in negative 2, the negative 2 times negative 2 plus 3 is positive 1. Negative 2 minus 1 is negative 3. So remember, I'm plugging it into the factored form equation. That's positive 6, so it's going to go straight up here. And then 1, negative 1 is negative 1 times 2, right? Negative 1 plus 3 is 2, and then negative, negative 2. So it will be positive 4. So it would be something like right here. And it goes, and looks like it's going to go down. If you plug in 0.5 or 1/2, or 1/2 plus 3, 1/2 minus 1, to be 3.5 times negative 1/2 times 1/2. If you multiply this out, be 0.5 times 3.5 times 0.5, 8.75, and it's going to be negative because of this negative sign here. So it's going to be less than 1. It's not going to go too far down. And that will be your graph. Okay. Right. All right. Let's do the rational. It'll be x minus 1 all over, I'm just going to factor it, x minus 3 and then x plus 2. So our horizontal asymptotes are at 3, 1, 2, 3. And negative 2. And because the power on the bottom is bigger than the power on top, let me put these in blue. Then the horizontal asymptote is at y equals 0. All right. So if you plug in like a negative 3, you will see that it goes this way. If you plug in a 4, you'll notice that it goes this way. And if you plug in all the numbers, let me look it up again. Plug in all the numbers, x minus 1, x minus 3, x plus 2. It's going to look something like this. It's going to look something like this. Okay. Got to plug in numbers though. Just plug in negative 1, 0, 1, and 2. Okay. Number 16 is a log problem. Remember, they both have the log and the same base. So, and you're multiplying 2 and the log of x, so that'll be 2 times x is equal to 7x minus 3. So you subtract 7x. it'll be negative 5x is equal to negative 3. Divide by negative 5, x is equal to 3 over 5. Right? Number 17, use synthetic division. Remember, you put the opposite sign, negative 4 of the divisor, and you put 3, 11, negative 6, and negative 18. To bring the first number down, that's 3. Multiply this number and this number, that's negative 12. Add these numbers, 11 plus negative 12 is negative 1. This is positive 4, negative 2, positive 8, and then the remainder is 10. Okay, so if you look at it, it'll be 3x squared minus x minus 2 plus 10 over x plus 4. Okay. Number 18, we're almost there. Okay, so we have the sign of negative 1/2. The sign of negative 1/2 is down here, so it'll either be at 7 pi over 6 or 11 pi over 6. Right? And the cosine has to be less than 0. So the cosine in this, so this is 1/2. If the cosine is less than 0, that means that we're on this one right here, 7 pi over 6. So we have to find the cotangent of 7 pi over 6. Remember, cotangent is the cosine of 7 pi over 6 over the sine of 7 pi over 6. The cosine is radical 3 over 2, or negative. And the bottom is 7 pi over 6 is the sine, so that's negative 1/2. Flip it over, it'll be radical 3 over 2 times 2 over 1. Negative and negative, cancel, cancel. It'll just be radical 3. Okay? That's the cotangent. Number, letter B. We have the opposite, which is 12, and the adjacent is 16. Pythagorean, you have to use the Pythagorean theorem, so it'll be 12 squared plus 16 squared equals c squared. This is what? 16 times 16 is 256 plus 144. Oops. So 144 plus 256. It's 400, square root that, so this is going to be 20. So they're asking for what is the secant or the cosecant. Or secant theta is equal to 1 over sine theta. Sorry, cosine theta, oh my God. Cosecant theta is equal to 1 over sine theta. So in cosine, we need the adjacent over hypotenuse, right? And remember the theta is right here. It's always as close to the center as possible. So the adjacent is 16 and the hypotenuse, so the cosine of theta is equal to 16 over 20. The sine of theta is equal to 12 over 20. Now we need to just flip it over for the secant. So these two are related. So it'll be 20 over 16 with the secant, and it'll be 20 over 12 with the cosecant. Okay. All right. Number 19. It is 6 minus I over 2 plus I. You just multiply by the conjugate. So it'll be 12 minus 6I minus 2I plus plus I squared. all over 4 minus I squared. Again, remember they're conjugates of one another, so we don't need to multiply the middle section. So let's combine like term. This is -1. So it'll be 11. 12 minus 1 is 11 minus 8i all over, this is -1, so it'll be 4 plus 1, which is 5. That's your answer. Find the exact value of the inverse operation of tangent and sine of -1, 12 over 13. Well, let's look at this right here, the sine of 12 over 13. So here is opposites over hypotenuse. So this is 12, right? That's 12. This is 13. So this is going to be 5. Sorry, it's not drawn to scale. All right, but it's helpful because you need to find the secant. The secant is the opposite of cosine. So cosine of theta is equal to 5 over 13. That means that the secant theta is equal to 13 over 5. The sine of theta is equal to 12 over 13. The cosecant theta is equal to 13 over 12. Okay. So you know. So sorry, I think a tangent. So the tangent of that would be, so tangent of theta is opposite over, it would be 12 over 5. Okay. Number 21, I wanted to put in because I know a lot of people had trouble with this, but be 4 over x plus 3 minus 2 over x plus 4. So basically, you need to get the common denominators and then combine the fraction. All right, so this is x plus 3, x plus 4. You need to get a common denominator. And this is x plus 3. So this is 4x plus 16 minus 2x minus 6 all over x plus 14, sorry, x plus 4, and then x plus 3. Combine like terms, so it'll be 2x plus 10 all over x plus 14, x plus 3. Okay, so that's all I wanted you guys to do. Number 22, notice it's a geometric sequence. So we need to calculate the 9th term. Let me look up the formulas real quick. It is a sub n is equal to a sub 1 Rn minus 1. The sum of a geometric sequence is a sub 1 and then 1 minus r to the nth power all over 1 minus r. So we have our first term is 2. A sub 1 is 2. The ratio is 4. So the formula here is a sub n is equal to 2, and then 4 to the n minus 1 power. And make sure you're not multiplying these out. Remember, there's an exponent here, so you can't multiply the 2 and the 4. Okay, it's tempting. All right, so that's the formula. Calculate the 9th value of the term. So you want to use the a sub n is equal to, let's see here. Calculate 9th term. So you just have to plug in 9 here. So a sub 9 is equal to 2, and then 4 times 8, because 9 minus 1 is 8. 4 to the 8th power is going to be a big number. The 6, 5. 5, 3, 6 is the a sub 9. All right. We're going to find the sum. The sum is the s of 9 is equal to the a sub 1. The a sub 1 is, if you plug it in here, the a sub 1 is 2. You also need the r. The r is 4. I think that's it, right? So, and the 9 is the, yeah, so the s of the sum of the first 9 digits of the sequence are, or is 2, and then 1 minus 4 to the nth power, that's 9, all over 1 minus 4. Before the 9th power is 206, so it'd be 2, and then 262 negative 143. Remember, you're subtracting 1, all over negative 3. Two, 6, 2, 1, 4, 3, and then times 2 divided by 3. 174,762. Okay, so that's the sum of the first 9 terms. All right, number 23, almost there, is the cosecant. So it'll be, remember to push everything in sine and cosine. So it'll be 1 over sine x plus cosine x over sine x, all over sine x over cosine x plus sine x. So on the top, it's 1 plus cosine x over sine x. And on the bottom, we'll multiply it. We'll multiply both sides by cosine. So I'll multiply this by cosine because I'm a denominator, right? So it will be, right, over cosine. So that will be sine x plus sine x cosine x all over cosine x. Remember, you're dividing this, and then you're going to multiply by its reciprocal, so it'll be 1 plus cosine x over sine x times cosine x, right? And then on the bottom, I'm gonna factor out sine x. It becomes 1 plus cosine x. I cancel these out here. That becomes 1 over sine x times cosine x over sine x. Cotangent is here. And 1 over sine x is cosecant x. That is your answer. You've proven the identity. Right? The last problem, number 24, is 2 sine squared x is equal to 1. Divide by 2. Sine squared x is equal to 1 over 3. Square root both sides. It'll be sine x is equal to radical 1 over radical 3. sine x is equal to 1 over radical 3, and then multiply the top and the bottom by radical 3. So sine x is radical 3 over 3. All right. Oh, this is 1 over 2. How do I get 2, 3? I'm getting really sleepy right now. Let me erase this, sorry. So this is 1 over 2. 1 over 2. So this will be, you have to rationalize it, so it'll be radical 2 over, sorry, let me just do this. Sine x is equal to 1 over radical 2. Multiply radical 2 over radical 2. It will be sine x is equal to radical 2 over 2. Remember, we want to find x, right? So the x is 45 degrees. And where is it 1/2? And is quadrant 1 and quadrant 2, where x is positive, and so that is 135. So it's going to be that's going to be the 2 answers. And remember, you're finding all answers between 0 and 2 pi. Okay, and that is it, my friends. We've completed it. Good luck.